Well, for the first question, if fxy is a valid probability density function, it should satisfy this equation, and in this case we should pay attention that the bound of x is from 0 to y, and the bound of y is from 1 from 0 to 1, so we can know that the b equals 8. And according to the definition, the probability density function of x equals this one, and the probability density function of y equals this one. And in this case, y is from x to 1, and according to the feasible region shows here, so that we can know fx equals this one, and the same we can know that if y equals this one, we should pay attention that the bound of x is from 0 to y, so we can calculate this part. And if x and y are independent, the probability density function of x and y should equal the probability density function of x multiply the probability density function of y. And in this case, we know that these two parts doesn't equal, so it's not independent. And for the fourth questions, we know that the mean of x equals this part according to the definition, and thus we can know that the mean of x equals 8 over 15, and it's the same that the mean of y equals this part according to the definition, and we can know that the mean of y is equals 4 over 5, and just the same as we're dealing with these two parts, the mean of xy equals this part according to the definition, and we should pay attention that dealing with these functions, and we should pay attention to the bound of x, which is from 0 to x, and the bound of y is from 0 to 1, so that we know the mean of xy equals 4 over 9. And if x and y are uncorrelated, the curve of xy should equal 0, which means that this function should equal 0. But how in this case we calculate that this part equals the minus the product of these two parts doesn't equal 0, so it is not uncorrelated, and the conditional density function of this part equals this one according to the definition, so we can calculate and plot the diagram of this part is like this, and the conditional functions when y equals y, and this part equals this one, and we can draw it. Its diagram is just like this. And the final questions, we know the mean of x when x equals x at that point, this part should equals this one, and this one is here, so that we know the mean of this part is equals this one, and when y is at exactly that point, we know the mean of this part is equals to this one. Their solutions are the same, so that we can calculate the result is 2/3 and multiply y. And for this part, because x is no longer at a single point, it has a region which is from x1 to x2. In this case, is from 0 to y, so that this part is different than this part. It's changing to this one. So after some calculation, we can know the result. We can know the result of this one is should be like this, and when y is no longer at the single point, their method to solve this problem and to solve these problems are the same. We should pay attention to that y is from y1 to y2, which in this case is from x to 1, so that this conditional density function is like this one according to the formula, so that in this case we can calculate that when y is from x to 1 and this mean is equals to this part, and we can calculate this result by some steps.